Okay, then we'll start with the C sharp, okay? So this is how an empty script looks like. This here is the name of the script. So class and script basically mean the same thing. So let's start with variables. We use variables to store information. So if I say here some int, that's an integer. So that means whole numbers like 0, 1, -1, 5, stuff like that. Then you have float. That's a whole number, so with decimals. Then you have string. That's text string. You have char, so that's just one character. So a string has multiple characters and the char is just one. Then you have bool. That is either true or false. Okay, and you see all these variables here by default, if you declare them like this, are private. So this, if I say private before it, it's the same. By default, it's private. And private means you cannot see it in the inspector of Unity, and you cannot access it from another script. That's what private is. If I say public, then you can see this variable in the inspector, and also you can access it from other scripts. But these are just one value. So if you make these square brackets after the type of variable, that's an array. It's no longer one value. Do you know arrays? Do you know arrays, or should I go through it? Okay. Oh, I see. Okay. Okay. We'll go through everything. Okay. So this is not just one value. This one, now this holds multiple values. But right now there's nothing inside it. If you write this, you create space in memory for this array. But let me show you in Paint what an array is first. So you can imagine it's like something like this. Okay. So let's say something like this. So this is position 0. Okay. So the first thing you need to know is that array starts from position 0, not 1. Okay. So this is an array of length 9. So it's of length 9, and then inside you have values. So something like that. Right. So that's what an array is. And you also have lists. So that's similar to an array, but the difference is an array has a fixed amount, a fixed length. Okay, you cannot. You usually use arrays when you know how many elements you need. Lists are used when you don't know how many elements you need. So let's use the start function of Unity. Okay, so what this is, whatever you put inside here happens at the start of the script. Okay, so let's say this here. So that means we create an empty list inside that variable. Okay, and now let's say we want to add some values there. Okay, and let's add a couple more. Let's add like 5 values here. Okay. Okay, so let me show you how this works. Okay, so the first thing you need to know is the code executes from top to bottom. Okay, so first we create an empty list and then we add these values. So how this will look like is that's the first thing that happens. So we add 1. Now it's length. This is position 0, right? Then we add -4. That's position 1. So that's how it works, right? You add it to the right. So after all these lines here, this is what you have at the end. So you can see that you can when you add a value, it changes the length of that, unlike the arrays. Does it make sense? Okay, and you can have this can be anything. In this case, it's an integer, so whole numbers. But these arrays and lists can be of anything, of type float, string, bool, and you'll see that this can be even components or scripts that you make. This can be anything here. Let's see what else. Let's go through for loops. I'll show you. Let me first write it. Let's start with the basic one. Okay, you see this? You use this to repeat some code. So whatever you put inside the curly brackets here, it will be repeated. For in this case 10 times. So you have you go from 0 to 9 because this here means strictly smaller. So we create an integer, and by the way, this integer here exists only in this for loop. Also, let's delete this stuff, and let's say we make a variable here in the start function. Okay, this here exists only in the start function, so the variables only exist within the curly brackets that they are in. That's also important to remember. So this will repeat. It will repeat. Let's see. Yeah, 10 times. So how this works is we start with value this I is 0, does the stuff inside, then it increases it by 1. So that's what this means here. I++ means we add 1 each time we go through the loop. So it's 0, we do the stuff, it's 1, we do the stuff, and it repeats 10 times in this case. But let's look at how to go through an array or a list. So let's say we want to do something with the values inside the array. Then we go from 0 to the length. So you can say that array dot length. So now this will grow from 0 to how many elements there are in the array, and then you can do whatever you want with those values by saying, let's say we want the sum of all of those, right? Let's say sum. By default it's 0. Here we say sum plus equal, so we add to that, and then we specify. So this here means the value at position y I in that array. That's what this means. So what we did here is we calculated the sum of all the elements inside that array. Is that clear? Okay then. And the same for lists. Let's say we want to do it with the list. In that case, it's exactly the same, but you say count instead of length. Let's look at if statement. So that's very simple. You just have a condition, and if that is true, then you do some stuff. So and most beginners say this is true like that, right? If that bool is true, let's say that's one condition. But if you delete this equal true, that also works the same. That means if this is true, and if you say if you put this symbol, that means if this is false. So that's also true, because you can say also this is equal false, but this is simpler. You don't have to write that. So that's if you have a bool, but most of the time you won't have a bool. You'll have some sort of condition. So let's say that integer is bigger than I. That's a condition, and then what you can do here is so this will, whatever you put inside here will happen if this condition is true. But you can also combine conditions. You can say this, and this is the and symbol. Let's say some bool. So that means if this is true and this is true, you do the stuff inside. And obviously, if one of these is false, then the stuff inside will not happen. But you can also say or. That's the or operator here. So that means if one of these is true, you do the stuff inside. Then you have else. So that means if this first condition is false, you do some stuff here. And you can also say else if. Okay, so that means the condition in the if was false, and then you also check for a condition, for an extra condition here. So that's also I think, but you can, after an else, I think you can say else again. I'm not sure. I don't know. But let's look at the while. So we discussed the for loop. While is similar. So the difference is you use for when you know how many times you want to repeat some stuff. But what if you want to do something while a condition is true and you don't know how many times you want to repeat that? In that case, use a while. So this will do the stuff while something is true. So you have a condition and it will do the stuff while this is true. And that's everything you need to start programming in Unity. Um, let me think. Oh, there is also one more thing. You can say this is a classic for loop, but you have something called for each. So let's say integer some int in that array. But oh my bad, some int array. That's you use this when you want to go to the elements of an array with this, and then you can say here sint and do stuff with that. So the first time you go through the code, this is the first value inside the array, and when you go again, it's the second, and so forth. That's how this works. Okay, time to look at some Unity stuff. Let me show you this in first. This is a very simple example of a 2D platformer. You have this guy that can walk and jump on these platforms. That's everything, as you can see. Let's start with the most important thing, the interface. So you see this in the top left is the scene view, scene panel, where you can see your elements in the scene, and you can use this tool here to move, rotate, or resize this. You can move this on a specific dimension with arrows if you want. Below we have the game panel where you can simulate the game. So in here you press play here on top and you can simulate the game. You have the console here where you can debug your code and see errors. You have the project panel where you have your assets, and I recommend you organize them like this. You see I have animations, audio, prefabs. Prefabs means saved objects, scenes, scripts. So it's good to keep these organized. Then you have the hierarchy in the top right. That's where you can see all the elements inside the scene. This on the top is the name of the scene. And then you have the inspector where you can see the properties of each object. Now, all scenes must have a camera. So this can be 3D or 2D. In this case, orthographic means 2D. And you have some settings here, like zoom. With this, you can zoom in and zoom out, as you can see. There are some other options that I don't know about, but that's not important. What is important is all objects have a transform component. So that represents the position in space, the rotation, and the scale means size. But let me show you what a vector tree is. Because you see you have X, Y, and Z. That's a vector tree. That's what we call a vector tree in Unity. And the vector tree can be two things at the same time. So let me use paint here. Let's imagine in 2D space. Okay, and let me draw some lines here. So say here we have 1, 2. Okay. Let's say we have a vector 3, a vector 2. This is a 2D space. Okay, so vector 2. Let's say we have 3, and 1. Okay. So, but wait, I said 3, so let's make 3 here as well. So that means we have this point here. That's what that means. But it also means this line. Okay, so let's say when we want the position of an object, or we want to move an object to a specific position, then we consider this vector 2 as a point. But sometimes we want to move an object, and in that case we consider this a line, like that. So the object will move this amount and in this direction. So it means two things at the same time. Does it make sense? That's okay. Okay then. So that's in 2D space, but the same is in 3D space. Now let's look at some important components. In this case, we have the player here. It has a sprite render, so this displays an image. And you see you have some different properties here. Sprite is the sprite, the image that you want to display. The color here, very important. In this case, we already have images of this character that are already colored. So if you modify this, it doesn't look good. You only can modify this if you have an image that is white or in grayscale. Otherwise, it doesn't work. You can flip it here on a certain dimension. Simple is just one image. If you say tile, then you repeat that image. So if I say here, it repeats that image. It's good for platforms or backgrounds or textures. Okay, then you have sorting layer. That's with this you put some sprites on top of others. So in this case, you see the background is on layer 0 and the player is above it because it is on layer 2. So that, but these are sub layers. You can create whole layers here as well. And very important thing you need to know is that all these properties can be used in code. 95% of all properties in here, you can get this in code and modify them in code. So we have the rigid body in this case, rigid body 2D. That gives physics to the object, the player. Dynamic means it interacts with other objects physically. It is moved by other objects. If you say kinematic, if you change it to kinematic, that means it can only be moved by script, so it will not interact with other objects physically. And static means it doesn't move. You have mass here. You have linear damping. That's basically resistance to movement. Angular damping, that's the resistance for the rotation. Gravity, so how strong the gravity is. In this case, we want gravity on this guy. And then here, constraints, you can freeze position on a certain axis, or you can freeze rotation. In this case, because this is dynamic and interacts with the platforms, I don't want my guy to rotate, so I freeze the rotation here, you see. Then we have the box collider. What this does is it allows the player to stay on the platforms. If we say trigger here, okay, that means it will not it will have the collider, but without physics, so it will not interact with other colliders, you know. So and then we have the animator here, okay. So this is the animator panel. So here you see we have some animations for the player. The orange one represents the default one, so the one when the scene starts. This is what will be played first. And you see the lines here are transitions from one animation to another. So if certain conditions are met, you transition from one animation to another. And for that, you see this in the corner is running. That's a bool that I created, so it's a parameter. And rigid body y, so that's the velocity on the y-axis. So the movement speed on the y-axis here, basically, which is a float. And I have conditions here to transition from one animation to another, and I enable this in the script. So let's look at the script. Okay, let's not let's get straight into the straight into an example. Okay, so this is for the player, the controls for the player. So we need a couple of components. Okay, we need the sprite renderer. Why? Because we want to flip the player so that it looks in the direction in which he's moving. So that's why we need the sprite renderer. We have an animator. So with this, we want to enable and disable animations. We need the rigid body to move the player. Then we have a float for the move speed, a float for the direction, and you'll see that in a second what that is. And then we have a jump count to control the jumping and the maximum jump count. So that's the maximum amount of jumps possible. And then we have a float for how for the jump force, so how high we jump. So in the start function, so this happens at the start of the scene. Actually, not at the start of the scene. So actually, this happens at the start of the existence of the object that has this script. That's because you can spawn an object while the scene is running, and when you spawn it, you will do this first, right? So we use the get component. So this will get a component from the object that has this script, because you can also specify a specific object here. You can say, let's make an object here, some object. You can also say specify an object and then that get component, and that will get that component from that specific object. But if you do not specify an object, then it will get it from this this object that has the script. So we get the components and place them in the variables that we created, and by default here the jump count is 0. And then void update, whatever you put in here happens in every frame, so it happens very fast. So every frame we want to know, we want to get the input from the player, so we know if we're moving or not. And here you have some options. I use the get axis horizontal. So what this is basically is, it is -1 when you go to the right, to the left. It is 1 when you move to the right, and it is 0 when you don't press anything. And when you go from 0 to -1 or 1, you don't go instantly. It goes fast, but over a period of time, it doesn't go instantly. So I use this because it makes the movement smoother. But you can also use, you can say if input. Let me show you how to get input. Okay. So usually you get input every frame. Let me show you the classic way to do this. Key code space. Let's say we want the space bar. So this happens when you press that space bar. But you have some options. If you say get key down, that means this will happen once at the exact moment that the key is pressed down. But if you say get key without down, then this means it will, whatever you put in here happens while you press it. So it happens multiple times while you hold that key. And you also have get key up. So that means when you release a key. And here you say key code, and you can specify any key here. But in this case, I use the horizontal axis. So this works with ASDW and the arrow keys. And horizontal means only left and right movement. So once we have that, we check if you're moving. So if that is different than 0, then here we flip the sprite to look in the direction in which it is moving. So you see here if it's bigger than 0, so that means if you're moving to the right, then we check if it is flipped correctly, and if it is flipped incorrectly, and then we change it if necessary. And same for the left. And then here you say animator set bool is running true. So what this means is get animator, and then we take that parameter which is a bool and set it to true. So this will enable the animation by changing the parameter in the animator that we created. And then else, so if you're not moving, we disable that. We say it's false, running is false. And that will disable the running animation. Now for the jumping, first we check if we can jump. So if our jump count is smaller than the maximum. And if we can jump, that we check for input, for W in this case. And you see it get keyed down, so that means it happens once when the key is pressed down. And here we change the velocity, linear velocity. That means the speed in the direction of the rigid body that I told you that gives physics to the object. So we modify, and in 2D you can specify a dimension. You see, we have the y dimension of that linear velocity. So we change that to jump force, increase the jump count because we jumped, and then we enable the animation. This time without transition, so you can play a transition by script to a specific animation without using the conditions. So if I say play this, it will play that animation. And then we here every frame we update the velocity on the y-axis of the rigid body in that animator, so this will transition to the falling animation if necessary. And in fixed update, so why don't we put this in the update? You see in the fixed update we change the velocity on the x. If you do physics every frame, you have to do it in fixed update. I don't know the explanation, but that's how you do it. So you see for the x, for the movement on the x-axis, we say move speed times that move direction. And then here we have on collision enter 2D. So whatever you put in here happens on collision, on physics-based collision. And then here we check if we collided with the platform. So we say if that collision and then the collider, so what we collided with, compare tag is the platform, then we reset the jump and go back to idle. But let me show you what a tag is first. So a tag is a category you give to an object. You see here in the inspector, in here you can create your categories. And also you have layers. So these are not categories. This is for physics. You can have different physics layers. And the reason is if you go here to project settings and then physics 2D, you have the layer collision matrix. So here you can disable or enable interaction between layers. So sometimes you want, for example, you want the player to interact with some collectible stuff, but the enemy no, or maybe some projectiles must interact with the player but not with the enemy. So in that case you want to disable that interaction with this here by having different layers. Now you have some versions of this. Let me show you, because this is on collision enter. So when you touch something, when this touches something, or that's not quite correct. When you enter a collider, but you also have void on collision exit 2D. So when you exit a collider, and you have on collision stay, which is while you're touching a collider, you do the stuff inside. And most of the times you want to filter this collision, so you want to check for a specific type of object before doing the stuff like we do here. We check for platform. And you also, but these are physics-based collision. You also have on trigger enter 2D. So that means on collision that is when you enter a collider that does not have physics enabled. So it's a trigger collider. And you are here. You also have enter, exit, and stay for this. So you have physics-based collisions, and you have collisions that do not have physics. So that's. Do you have questions until now? If not, we'll go to another example. Should I go? Should I explain everything and then we'll discuss your project? Okay, let me show you some stuff. So we discussed this is a 2D platform. Let me show you a tile map, okay? Because the platforms here that you see here in the scene are made with a tile map. Well, first you need the tiles, and I do have them in this image here, you see. But when you import it, this is just one image. You have to split this into multiple images. So the way you do it, you select it, you go here, open Sprite Editor, and you slice it by cell size. So in this case, these are 64 times 64. You click slice. Wait, it's not. It's 16. 16 times. In this case, it's 16 pixels. You slice and then you close this, and it will save it. And um, very important thing. You see here pixels per unit here. That needs to be the exact size of those tiles inside this image. So each square must be, if each square here is 16, then here you have to put 16 pixels per unit. And if you have pixel art like this, filter mode, you have to set it to point, no filter, because by default it's bilinear. What that does is it for high resolution images, it combines the pixels to make it look smoother, but we want to see every pixel because this is pixel art. That's the reason. So once you have that split into multiple images, you have to create a tile palette. Okay, and I already have it. So by default, this here will be empty. So I just select everything here and drag and drop them here. And with this, you can draw on a tile map, but first you have to create a tile map. So you say you right click here in the hierarchy, 2D tile map, and you can have tiles of different shapes. In this case, it's rectangle. The shape is rectangular. So we have a rectangular tile map, and this is the tile map here. You can see here in the hierarchy. And it behaves a bit like a sprite renderer in the sense that you can place it on a specific layer below or on top of other layers. And because I want these platforms to have physics, I also have a tile map collider. So what this does is it creates a collider on each tile here in the tile map. So I don't have to do it for each platform. I just add this tile map collider. And then you can paint here. So if you go to the tile palette, you can paint here whatever. You select a tile and then you see you can paint this. The tools to paint. So that's what the tile map is and how it works. Let's see what else I can show you. Let's look at UI stuff, okay? So here I'll show you three things, okay? This is a bit advanced, but I think you'll understand it. So UI by default, if I make a canvas, okay, so this will, when you have UIs, UIs are inside the canvas. So this canvas here is on top of everything. And when you have a canvas on top of everything, you use it for stuff like loading screens, HP bars, I don't know. Let's see, you play an RPG, you have an inventory, stuff like that. So if I add a panel here, you see it's on top of everything. And let's say I add some text here, you see it's on top of everything. So that's a normal canvas. But sometimes you want UI elements in world space, in the world space. So in this case, let me show you the scene. You have this guy here, and it just displays some text here inside this bubble. You see, so it just displays this with a sound effect. You see. So let's look at how that works. First of all, we have a canvas in world space. So if you go here into the canvas component, you see render mode here. You have overlay, which is the one that is on top of everything. And then you have world space. And what that does is now this canvas behaves as a sprite. So all elements inside this canvas will behave like sprites. So what I have here is an image. So it's kind of like a sprite in this case. But the thing is, very important thing, all of these UI elements will be on one layer. You cannot, for example, make this the image on one layer and the text on another layer. All of those are in one layer, specific layer. So we have an image, and then as a child we have some text here, which is empty by default. That's a text. And let's look at the code, because I want to show you what a coroutine is. Let me see if I can find that the dialogue here. Okay, so here you'll learn a couple of things, how to use sound and how to use a coroutine. So I have an audio source somewhere, I don't know where actually. Yes, I have an, you see here this audio source on the player. So with this one you play sound, background, play music or sound effect. In this case it's a sound effect that loops, so I check the loop here. And then in code, I get that audio source here in this variable. Also, we need the text, you see, because we modify that text. We need an array of strings, So we have the text that we want to display. Char speed is the, you see that we add character by character here. So that's the time difference between characters. And then we have a line speed, so that's the time we wait between texts. So because this process takes time to spawn those characters one by one and the lines one by one, we have a coroutine. So you use a coroutine. When you have a process that takes time. So in other words, it's like a function, but you wait some time inside it. But I forgot to show you functions. Let me show you functions before we get into that. So let's go to this test script. If you say void, so void function, that's a void function. So it does some stuff in here, and in other words, you give some name to some code. So that way you don't have to repeat the code. You can just use the function to use that code. So void, it just does some stuff, but you can say also, let's say int. So if it's not void and it has a type, then it must return a value. So it does some stuff, but it returns a value of that type. So let's say we want to get the sum of an array. Okay, so let's say here integer the array. Okay, and let's make a sum variable, 0 by default. We start from 0. And let's say we want, actually let's not use a parameter here. These are called parameters. Because, let me explain, okay? Let me show the first thing. Let's say we want to calculate the sum of all the elements inside this array. So we say for integer 0 to the length of that. So that length, I++, so we add 1 each time we go through the loop. And then here we just say sum plus equal that array and then the position I. And you see it gives us an error because we have to return some int at the end, so we return the sum. You see. So with this, we calculate the sum and then we return it. So what that? Let me show you what that means. So here we can say for example, in the sum, let's say equal to that function. Okay, so this function will calculate the sum and return that value inside these variables. That's how this works. But with this function here, you see we calculate the sum from a specific array. But what if we want to do this for any array? In that case, we use a parameter. Okay, we create a parameter here. So when we use this function, we'll use it with whatever array we specify. And then here we modify this code and say that array length and that array y. So now we can say here in the function, we can specify an array. So I can take that array and put it here. So now this function does not work with just one array, it works for any array of type int. Does that make sense? Okay, then, so that's what so the void function just does some stuff, but a function with a type returns some value of that type at the end. Now, that's kind of what coroutine is, but a coroutine, in a coroutine you wait time. So I numerator means coroutine, and then you give it some name, and you can even have parameters. In this case, we don't need any. So let's see. Let's look at how this works. So we say for each line in the dialog line. So we go line by line here. And at the start, when we start adding those characters, first thing we do is we enable the sound effects. We say that audio source dot play. So this start that audio source, and it has the loop enabled, so it will loop. And then we have to display the line character by character. So we say for each character in that line, we add it to the text. So the text right now at the start is empty. So that's what we do. We say that text plus equal C, which is the uh, these are the characters inside that line. And then you see we wait some time between those characters. So yield return new wait for seconds means wait this amount of seconds. So after we show the after the text is finished, we stop the sound effect, and then we wait some time between the lines now. So the same yield return new wait for seconds. So we wait some amount of time, and then we reset that text at the end. We make it empty. That's how this works. But you also have another thing, yield return null. So that means wait one frame. So these are completely different. This is one frame, and these are an amount of seconds. And you'll see that yield return null wait one frame. You have to do this if you have a while. Actually, sometimes in for also. So that means wait one frame. Is it clear? Does it make sense, or should I explain more about this? About the yield part, yes. So again, this means wait this amount of time that you specify within the parentheses here. So it means wait that amount of time. That's what that means. That makes sense. And then so that means, okay, let me show you. Okay. So if you say this yield return null, that means wait one frame. If you say yield return new wait 4 seconds, and then you specify one, let's say, that means wait 1 second. Okay, does that make sense? Yes, you wait time with that. You wait time. So you can wait an amount of seconds or one frame, depends on what you're doing. In this case, we wait time. Let's see. Let's look at some other very important code. Let's look at raycasting. Okay, so let me show you the scene first. We have these guys here, and we can click and drag these around. You see? So you can click and drag this. Let's see how to do that. This is a bit more advanced, but okay. So we need a couple of things first. We need a game object. In this variable will save the object that we click. So when we click it, we save it in this variable to be able then to move it. We have a layer mask. You see, that's for physics. So with this, we target a specific layer when we click and raycast. But what is a raycast? Okay, because you see we have here raycast, this stuff here. So a raycast is kind of like a collider in the shape of a line that lasts one frame. So you use it to detect stuff in one frame. So let's look at the code. We do it every frame because so every frame we look for the left mouse. So you see, get mouse button down, left mouse. but you see it's get mouse button down, not button. So that means this will happen only once when the mouse is pressed down, at that moment when it's pressed down. So when we click, we want to detect that object. So what we do is we take the mouse position and convert it to world space. That's what we do here. You see, we have a vector 3 mouse position. We say this camera stuff. So we have input mouse position. That's the position on the screen, and we use this to convert it to world space. And after that, we make sure that the Z is 0 on that position, because in 2D all objects are on 0 on the Z-axis. Then we raycast that position that we have now. So the mouse position in world space. We give that raycast that ray a length. And this is a bit weird because we do not raycast in a specific direction. We raycast at exactly that point with this. So we say raycast hit 2D, that will save the information about the raycast. And then we create that raycast. So we say physics 2D raycast. The first parameter here is the position. So where do we start that line? So we started at mouse position. Vector 2,0, that means at exactly that point. And then you have to give it some length, because otherwise it doesn't work. I don't know why, but you have to give it some length. And then we also specify a physics layer. So this will only touch a specific layer, physics layer. So after we do that, we check if we collided with something. So we say if hit that collider. So hit is the information about the raycast, that collider. So that will be the first thing that it collided with. If it's different than null, so if we collided with something, we save that object here. You see, we save it. So we say current object equal hit collider that game object. And then we have some logic for moving it. So if that current object is different than null, so in other words, if you're holding an object, we have to move it to the mouse position. So we take the mouse position on the screen, convert into world space, and then we just teleport the object to that position. So current object transform position equal to mouse position. That's what we do every frame. And then here, when we release the mouse, we want to make that object null, so we no longer control that object that we had. Does it make sense? Or so a raycast, basically you use it to detect stuff. It's a line that exists one frame. So what do you think? Is this difficult or? I'm just trying to show you what exists, so then you can use it. You can, because when I started, I didn't know about this stuff. Yeah, you don't have to understand the code. You just need to know that these tools exist. That you just need to know what exists to then search on Google. So again, this is a collider in the shape of a line that you create to detect stuff in one frame, basically. So it exists for like a millisecond or something like that. So that's raycasting. But what if you want to detect an object around some objects? So here I have a very simple scene. You have these guys, and when you press space, you create an explosion that pushes these guys. So you see, you have this. So let's look at that, because that's also some very important. So here we use something very similar to the raycast, which is overlap circle all. So this is like a raycast, but it's a circle. So it's a circle that exists for one frame, and you detect everything within that circle. So let's look at this. So we say every frame we check for input for spacebar to create that explosion. Now you see here, this is very important. This is how you spawn objects. But before that, how do you save objects? So it's very simple. You just drag an object from the hierarchy to the project here. So for example, I have this here. You see these are for, okay, let me go to that Synapse to show you how prefabs work. Oh, never mind. Anyway, these are, so with this you spawn saved objects. So instantiate means spawn. You specify what you spawn. You specify where you spawn it, and then this is the rotation, means this is just 0, 0, 0 on the rotation. And there are versions of this with different parameters that you can use. So we spawn the visual effect explosion, and then we create that circle to detect all the objects around us. So we say we make an array of colliders 2D, and this will return the objects around the objects within that circle. And once we have that, we apply force. I won't go to this, but we apply force to each object. Let's look at, so you also have that. So you have raycasting, and then you have circle overlap. And in 3D you have sphere overlap, so it exists in 3D as well. Let's look at top-down movement. Let's look at this. Oh, and if you want to destroy an object, you just say destroy and then specify the object. So you something like this: destroy game object. So if you say destroy game object, then it will destroy this object that has the script, but you can specify any game object to destroy it at the time. Okay, so you see I just click once and it goes to that position. This is very important because you'll learn how to move some object to a target. Okay, let's look at that. Top down. I do not see it. I have to open from here. So on click we move to that player to that position, or when it is close enough to that position. We have, okay, let's see. So we have the sprite render, animator, rigid body. These are just from the sprite render for changing the flipping the sprite, animator for the animation, the rigid body for moving it. We have a move speed, we have a move direction, which is a vector 2, and we have a vector 3 target position. So this represents the click. When we click, we change this. So in start function, we get the components, save them, and by default, vector to 0, move direction. And then here, if we click, then we get the mouse position in workspace, make the Z 0, and then the target position becomes that mouse position. And now we want to move, we want to create a move direction for the player. So what we do is, actually let me show you that in Paint. So let's imagine a 2D space. And then let's say this is the target and this is the player. When we say here mouse position minus the position of the player, what we mean is this. So that's what we mean. Okay. But you see that the length of this is different depending on where the target is. So if the target is here, obviously that's bigger, right? But we only care about the direction. So what we do is, you see here, we make that difference, which gives us this. but we say normalized at the end. So what this does, it converts this to something like this of length 1. The length of this will be 1 because we only care about the direction. We don't want the length of that vector. Okay, so normalized means it takes that and it makes it of length 1 but maintains the direction. So once we have that, we convert this vector 3 to a vector 2 because the rigid body needs a vector 2. So we maintain the x and the y, which the vector 3 will always have 0 on the z. We don't care about the z in 2D. Okay, so we have the move direction. When we click, we create the move direction and we save the mouse position as a target position. So we have the direction and the target position. Now every frame we check if that direction is different than 0, because you see by default is 0. So that way when the game starts, we don't start moving in a random direction. We do not move. So we use move direction equal vector to 0 to stop the movement. So if it's different than 0, then we enable the animation, we flip the sprite, and else if you're not moving, then we just disable the animation. And this is very important. Every frame we check if you reach that point. So what we do is, let me show you. We say target position minus the position of the player. Okay. So this time we're referring to this, the whole distance, not just the direction. Okay, the whole distance, distance. So we don't care about the direction here when we do this. We make that difference and we say magnitude, which is the length. So we only care about the length of this difference. And then if this is smaller than a distance that we choose, then we stop movement. So in other words, what this means is if you are close enough to that point, we stop movement. That's what that is. And this is the fixed update. We just update the velocity, so move speed times move direction. Does it make sense? Yes, you can use destroy object for breakable walls. So very important. I will repeat this again. When you want the direction from one object to another, you always have to take that difference, which is this, and change it to say normalize after you can make it length 1. So that way you can multiply it with whatever speed you want. That's very important. So that's how you get the direction towards an object. You say the target minus the position of whatever you're trying to move. In this case, it is the player to transform position. Let's see what else I can show you. I don't know. Let me think for a second. Let's look at some settings. Very important. How do you get assets from the Unity Assets Store? You go here. You see Window, Package Manager, and then you can search for assets that you saved from that the Unity Store. That's a bit. I'm sorry. But basically here you can get saved object and even Unity stuff. So tools from Unity. It does not work for me. I don't know what the issue is. Okay, you see. So you download it and then you import it. Import and it will that's your project. Let's see what else. For animations, this for time-lapse also here, tile palette. How do you change platforms? Here you see in the build profile. So again, file, build profile, and here you can change platforms. So you can make the game for different platforms here. And when you build your game, you must have your scenes in order. So scene 0 is what it will be played at the beginning when you open the game. And make sure to add all the scenes that you're using before building the game. I can show you how to get touch controls if you're interested in that. Are you interested in learning how to get touch for Android and iOS? Because I don't know what else I can show you. Yeah, I was asking, would you like to see how to get touch controls for Android and iOS? Okay, let me see if I remember. So let's do it in the test here. And let's say void update. One thing you can do is say if touch, not touch, input that touch count is bigger than 0, okay? So that's, if it's bigger than 0, then it means a finger is on the touch screen. And then you can get a specific touch now, because let me show you how that works in Paint, okay? Because these touches are saved in an array. Actually, I don't even think. Okay, let me try to explain this. So this touch, when you touch the screen, the touches are saved in an array like that. This is position 0. This is position 1. And these obviously are of type touch. So we'll just use an X to demonstrate this. That means there's a touch there, okay? So let's say we touch the screen once, okay? And then we touch, while the first touch is still there, we touch again. So we have 2 touches on the screen. That's how it will look like. We have this. And now let's say we remove this touch here, okay? What that will do is it will take this and move it there. And then you have an array of length 1. And I don't know if it's an array or a list actually. So when you remove this here, okay, this will go here, and then it becomes the first touch. So that's how this works. So let's say we want to do something with the. Let's say it's just 1 touch, and we want to do something with it. Touch. Excuse me 1 second. I'll be right back. I'm back. Sorry about that. Are you still here? Okay. So let's say we want to do something with that. Let's say touch equal input get touch 0. So that's the first touch in that array. Okay. And let's say we want to do something on a specific moment of that touch. We say if touch that phase, yes, touch phase equal touch phase, and you see you have some options here. You have begun. That means you just at the moment you touch the screen, ended, you remove that, cancel. So you have some options. These are phases of that touch, and you do stuff on them. So that's how you do it. Okay, so you check if there are touches, then you get the touch that you want, and then you do stuff on depending on the phase of that touch. But also you can use UI for the for mobile games. So uh, that's how you do it in that's how you do it in Android, like a mobile pen. Um, Anything, Android or iOS, any touchscreen. Oh, I don't know what you're saying there, but um, this is if you want to move stuff around while touching or stuff like that, maybe, or I don't know. Depends what the game is. Depends. Sometimes you use code like this, sometimes you use UI. Depends what kind of game it is. Let's see what else I can show you. I don't know. I think that's enough for today. I hope it was helpful. If you have questions or anything. Okay, then. Uh, you can say key code and then specify any key. Yeah, you say input that get key and then key code, and you can specify any key on the keyboard with that. So like that. Okay. Do you have any questions or anything? If not, then we're done for today. If I can help you with anything, just DM me. I hope this was useful.